Please take your seats.
Greetings, folks. How's it going? Excited to be here today. We're going to be talking about building Node.js applications on Google Cloud Platform. We're going to be building some apps, deploying them to App Engine, talking about taking those same applications, running them on Kubernetes and Container Engine. We're going to use the gcloud NPM module to connect our app with some of the cool services we heard about this week, things like the Google Cloud Vision API, Google Cloud Storage. And then finally, if we have some time at the end, we're going to dig into the way that JavaScript is helping change the face of the Internet of Things. We got a lot to do today. So before we dig in, a little bit about myself. My name is Justin Beckwith. I'm a product manager here at Google. And before that, I was a web developer at a bunch of places. If you want to take a look at any of the code we're going to do today, all of it's available on GitHub. Feel free to go check it out, clone it. If you want to ask any questions, reach out to me on Twitter at Justin Beckwith. And for me, this is really exciting because Node.js has been a big part of my development experience for the last 5 or 6 years. I was originally on an engineering team back in 2010. And when we kind of stumbled upon Node.js because we were primarily a front-end focused development team. And what was really attractive to us is that finally we were able to take all of these years of experience we had building front-end JavaScript web applications and apply that same knowledge, all that expertise we had built on the server side as well. We didn't have to split between front-end and back-end. We had one team that homogeneously could learn one language and then use all of that collective knowledge. And one of the things we were really surprised by when we started experimenting with it was that without doing very much work at all, we were able to get great performance out of our application. And you'll see that today, just kind of the way that Node.js is built makes it really easy to build performant web apps. When we started digging in, we started using Express as our web application server. And we were a little bit surprised by this because most of the frameworks we'd used before were part of the core of whatever language we were using. But most of the third-party most of the packages out there for Node.js, they're really not in the core. They're provided by this third-party module system called Npm. And it's wildly popular, and there's just about anything you could ever want out there with it. Just last month, there were nearly 4 billion downloads of Npm packages for authors of Node.js apps that were building and using these dependencies. And then over the last 6 years, a lot of things have changed. This started up as a technology where maybe if you were building a new app and you wanted to experiment, or you were a startup, you might decide to use it. But Node.js, it's ready for the enterprise now. There are real companies taking a big bet, and with things like the Node Foundation and an 18-month support cycle, it's finally ready to use for enterprise web applications. So in that same time, a lot of things have changed on Google Cloud as well, and it's now also a great place to run web apps. As it would turn out, Node.js is built on top of V8, the JavaScript execution engine that's used by Google Chrome. So we have years and years of experience fine-tuning JavaScript to run great on the client, and we're bringing that same expertise to helping build performant applications on the server. And when you are ready to bring them to us, you can take advantage of Google's infrastructure. So you're not worried about uptime, you're not worried about scaling. We're just going to manage all that for you. And then lastly, when you want to extend your application to use things like Cloud ML, Vision API, BigQuery, some of the cool stuff we've talked about all week, you can take advantage of our APIs and services. So when getting started, when you want to deploy your application to Google Cloud, really 3 places that you're going to look at. The first is App Engine. App Engine's been around for a while. It's the most storied part of Google Cloud. And the idea is, like I mentioned, you just bring your code, deploy it to us, we'll scale it, we'll manage it for you. If you're an organization that's already using Docker, Container Engine is a great option as well. It's essentially the Google Cloud hosted version of Kubernetes, and it's a great option for those of you that are already into the container revolution. And then finally, if you want to have complete control, you want to run a Windows VM, you want to run a Linux VM, and you want to kind of own that end-to-end, you can always create a virtual machine on Compute Engine. So first thing I want to do before we dig into the first demo is we had an announcement on Monday, and Node.js on App Engine just entered beta. So everything that we're going to do today, you're going to be able to go home and do as well. Whew. Thank you. So for the first demo, we're going to build a simple web application with Express.js, the most popular web framework for Node, and take a look at what deploying that to App Engine looks like. So I'm just going to use the Express tool, nothing App Engine specific here. And we're going to say Express, Node.js, next. And this is just creating an application on my local machine. So I'm going to do what the instructions tell me to do here. cd into the directory, and run npm install. Now, I'm installing these dependencies locally, but when you deploy it into Google Cloud, into App Engine, we're also going to run the Npm install for you. So if you have any native dependencies, they're going to get built on the right architecture. So just to show the standard app running locally, I'm going to do npm start. Our app is up and running. And let's take a look at this locally. So here, nothing fancy. We've all probably done this 100 times getting started with our projects. So let's make a simple change to it and then deploy it to App Engine. So I'm going to cancel this out, open up the project in my editor of choice. And all we're going to do here is, instead of it saying Express, we're going to say Express now on Google App Engine. Yay. All right. So when you're ready to deploy your application, you're going to want to go download the Google Cloud SDK, and that's at cloud.google.com/SDK. And this provides the gcloud command line tools that you can use to orchestrate your deployments, along with a lot of the other things we're going to see in the UI in a little bit here. So to deploy, I'm just going to do the gcloud preview app deploy. First thing it's going to do is take a look at our application and figure out, OK, this is Node.js. Let's generate an app.yaml, a small configuration file that lets us know what type of application you're running. And so I'm OK with generating that. And finally, it's going to tell us we're about to deploy our version, and we're off. And you can see here, we've got nodejs-next.appspot.com. This is a project that I had set up earlier. I'm deploying to a specific version because I don't want this to replace the version I have deployed out there right now. And behind the scenes, we're going to be going off and creating our app in the App Engine flexible environment. So this is going to take a little bit to deploy. While that's happening, let's take a look at a version of this that I've already deployed out to App Engine. So this is the Google Cloud Developer Console, and this is the Node.js project that we had just created and deployed into. The dashboard is going to give us a good oversight over the performance of our application, let us take a look at requests. We can also dig into things like latency, traffic, utilization, lots of interesting statistics available from the dashboard. What we're going to take a look at are the versions of our application that are actually available. So we just kicked off a new deployment. Every deployment into App Engine is going to create what we call a new version. Now, you'll notice that when we clicked on that link, when we started our deployment, it didn't say that it was just going to nodejs-next.appspot.com. It had this version number in front of it. And the reason for that is that every deployment that you do in App Engine creates a new version, and we want to give you the opportunity to go check it out. Make sure it works. Validate everything with your application and your deployment is working exactly like you expect it, and then only when you're ready, reroute all of your traffic over to this new version. Now, of course, during development time, you can set it up so that it does this automatically, but it's a really great feature if you're building an application that has to have 5 nines of reliability, and you want to be extra, extra sure that you're not going to deploy a bad build. But first, let's check out the version of this that I've already deployed. So I'm going to click here on the version v1, open up in a new window, and we have essentially the same thing that we just started a deployment for right now. Now, as well as this v1 version that's getting 100% of my traffic, you're going to notice we have yellow, green, red, blue. These are just 4 different versions of my app that I deployed that have a different background color. Now, the reason I'm bringing this up is because this versions feature, it's not just useful for validating my build before I take a new deployment into production. It's also great if I want to do things like A/B testing. What if we wanted to know which background color of our application is going to provide the best experience for our users, and we want to be able to go measure that and use that to make decisions about the product that we're deploying into cloud. What I can do is I can actually split the traffic across those 4 versions. So let's try doing that. I'm going to take 25%, 125% of blue, 25% of green, and so on until we get up to 100%. Finally, 25% of yellow. We're going to split on cookie, because otherwise this would be a difficult demo. Oh, that happens sometimes, so we'll just give it a quick reload. Lots of new things getting deployed this week. Some of this stuff you're seeing for the first time, so we're working out a few of the kinks as we go. Great. So, and look at that, our new version is actually available. So this is the version we just deployed. But let's do our traffic split one more time. I'm feeling good about it this time. So we have red, 25% to blue, 25% to green, and 25% to yellow. Save, and, well, we'll skip past that at this stage. That's OK. These things happen. New code. We just had to change out to the flexible environment. But the idea is that as I come back to this, what I'm going to see now is that every time traffic comes in, 1 out of 4 users will get red, 1 out of 4 will get yellow, green, and so on. So one of the things you might notice up here is that each of these versions that's running is behind mentions that we have 2 instances. Now, with the App Engine flexible environment, you can define how many virtual machines your application is going to run on. And you can limit that to 1, 2. You can tell us to auto-scale it, which it does by default, to go up to 20 instances by default. But one of the things that's interesting is that, unlike a lot of platform as a service systems you might have used, we actually expose the underlying infrastructure that your application's running on. So if we're going to get an idea of what's happening with V1 that's deployed over here, we can click in, and we can actually get the list of the virtual machines that are available. So now, let's say that I want to actually connect to this and SSH. You could SSH directly into that VM. So another useful thing that you can do from here is, let's say that we wanted to go and wanted to change. I'm going to try to do the set traffic command. Only this time, I'm not going to use the UI. I'm going to try to use the command line. You can also use this tool we have called the Cloud Shell. Cloud Shell is an integrated development environment that includes the Google Cloud SDK. All the commands that I was running locally on my terminal, you can run from here as well. So I'm going to do gcloud preview app services, or let's do versions list. This is going to tell us all the versions of our application that are deployed. And what I want to do is I want to set traffic so that we're going to route to the new version that we just went and created. And you can see it has a timestamp on it. So to do that, I'm going to say gcloud preview app services, and we're going to say set traffic. And when we do that, we could, of course, do a split here. But instead, what I'm going to do is just send all of my traffic to that version. And we'll say yes. And in just a moment, good, it looks like this one actually set. So now if I come back over here and go to nodejsnext.appspot.com, we're going to see Express now in Google App Engine, the version that we just deployed, up and running. And we were able to do that safely in a way that let us try it before we actually sent traffic to it. So this was a pretty simple application that we just made, right? But let's say that we decided we don't want to run this on App Engine anymore, or we want to run it in multiple places. What if you wanted to take that same application you just built and you want to go run it on Kubernetes? When you're ready to do that, behind the scenes, all we're really doing with the App Engine flexible environment is creating a Docker image for you when you do your deployment that is run on your virtual machines. So you can actually dig in and take control of the Docker container. You can customize it, redeploy to App Engine, or you can just take the whole thing and run it on Container Engine, Kubernetes, your own local machine, wherever you want to do that. So let's take a look at how this works. Right now, we create the Docker file automatically for you, but if you want to get a hold of it, you can say gcloud preview app genconfig -- custom. And what we're going to do is generate a Docker file for you. So quick show of hands, how many people here have used Docker before? All right, so a fair number. That's actually fantastic. I was a little bit worried I was going to start talking about Docker and everyone was going to get bored and get in that, post-lunch phase, everyone taking a nap. Don't want any of that. So this is the Docker file that we're using behind the scenes when we're actually building your image and deploying your application. But let's say we wanted to do something special. We want to do something different. I want to use ImageMagick. I don't know if anyone else has tried to use ImageMagick on other PaaSes, but it's kind of hard. Or I want to do something like use FFmpeg to do video encoding. All you have to do is come in, and just like you would normally do with a Docker container, do your apt-get. Well, first we'll do our update, and then your apt-get install ImageMagick. Now, when we do this, a standard Docker build is going to work just fine. Docker run, it's going to work. Deploy to Kubernetes. it's all going to work. And it's the same application that we're deploying to App Engine. There's no lock-in. We're not worried about it being vendor-specific. It's just going to be portable across any of this code will work in any of the engines that we have and on your machine and externally as well. So a few of the things that we just covered, the big thing I want to drive home with this is you can run your Node.js application as it is today. There's no lock-in. You can take the code with you, run it wherever you want. As far as NPM modules are concerned, use any NPM module you want, within reason. I happen to use Express for this application. Happy.js, we're going to see an example of that later. It'll work fine. Jade, any of the modules that you're using today are going to work just fine. We can automatically scale this to millions of requests for you. Out of the box, we're going to scale up to 20 instances, and you can bump that up as you need to. The version upgrades and traffic splitting features are really great, especially once we figure out why that wasn't working. And lastly, and most importantly, you can bring your own runtime with the Docker support. And it's not just for Node.js. This comes with all the App Engine flexible runtimes. You have complete control over that environment, and it's transparent. You can look in and see what's happening on the VM. So that was a really simple application. I mean, that was the classic kind of hello world deployment. But it's pretty rare that our apps in production are actually going to look like that. They're typically not just App Engine and one client hitting it. Usually they look like something like this, right? Like things start to get complex. We have multiple modules multiple microservices that we're managing. We're using things like scalable pub sub and message queues to get messages between them. We're using a scalable file system in the cloud to store all of our files and maybe serve them over a CDN. We need databases. We need things like Bigtable, Data Store, or MongoDB, or CouchDB, or RethinkDB, whichever database you're using today. We need to be able to run these. And usually our architectures end up looking something a little bit more like this by the time we're done. When you're ready to take advantage of all of these services that we provide, things like cloud storage, cloud data store, BigQuery, that's when you use the gcloud npm module. So I should say npm install --save gcloud into your project. It opens up access to all of the APIs and services that we have on Google Cloud so that you can expand and take advantage of the other services beyond just App Engine or Container Engine that we make available. And really these come in these big three buckets, right? There's storage for things like using your databases. You can use the databases we provide. You can use MySQL with Cloud SQL or GCS or Data Store. You can do that. Or you can bring your own with things like MongoDB on Compute Engine or on Kubernetes. We have all these cool things with big data. We've got BigQuery for accessing millions, billions of records in near real time. We had some announcements around Data Lab, PubSub for message queuing. And then you get into the APIs, which in my opinion, those APIs, these are the real magic of Google Cloud, right? These are bits of technology that we've been incubating here internally at Google for years and years and years. And finally, we're able to take some of these, wrap a simple API around them, and then make them available to you to use. Stuff like Cloud ML, speech recognition. I know it's something I've struggled with. The Vision API, detecting, if we're looking at a chair or an airplane automatically for you. These are the real magic of Google, and they're all exposed. I mean, think about the types of apps you could build with this. You could reach billions of people. You could change the world with the types of applications you could build with these services. I use these services to build an app about cats. That is actually my cat. So I'm sure, like many of you, I frequent Reddit. One of the Reddits that I enjoy is r/aw. And one of the things I noticed while I was on Reddit was that Reddit likes to talk a lot about how they like cats. And this comes up in the internet as well with developers who are all cat friendly. Yet every time I went to r/aw, I observed that I felt like I saw more dogs. I have a dog and a cat. And being a kind of, I needed answers to this, right? Like I didn't want to just leave it to perception. I needed to do this analysis, and I wanted to know, does Reddit like dogs or cats more? So a casual observation was not going to stand here. So what I did is I built an application, and what this does is it loads the first 3 pages of r/aw, and you can actually go look at this right now if you want to. You're about to see the same pictures. It loads them up, sends them into Google Cloud Storage, runs the Cloud Vision API against it to determine if it's a dog, a cat, or both, or maybe it's a turtle, I don't know. Figures out what it is, publishes those results back through Cloud PubSub, and then finally throughout the front-end module. Now you notice here I separated, we haven't talked about modules yet. I have an app engine front end and an app engine back end. So I've separated the concerns. You can do that inside of one application, and that way they can scale independently. I'm gonna have a lot more load on the back end process than on the front end process. And it's important when you're answering questions like this that you know you can scale, because I don't wanna wait, right? I gotta know. All right, so let's try it out before I keep talking about it. So this is Cloud Cats, and this is going to go do this analysis for us in real time. So right now we're going to Reddit. I hope it's up. And there we go. We're starting to get the first images in. And of course, the first one's, is that a bear or is that actually a dog? Either way, it's counting as a dog. That's all that matters. All right, the cats are getting back in it. We've got some cute kittens hiding behind there. That one looks like a tiger. OK, it's fine. Oh, we have cuddling dogs, funny ear dog. But you can see dogs on the right, cats on the left, and we're counting them all the way. And this analysis is happening in real time with the Google Cloud Vision API and PubSub. So all right, I feel like I've been seeing more dogs than cats. We've got about 75 images to process. That should count as like 4 dogs. Look at that. There were 4 dogs in that picture. And look at that. My casual observation confirmed with data. Organizing the world's information, people. This is what we do here at Google. All right, so let's take a look at the code. Oh, or maybe not. We'll get there. All right, into Cloud Cats. So first thing you'll notice here is we've got the web module and the worker module separated out as 2 independent Node.js applications. I'm going to dig into the worker. First thing I want to call out, as I mentioned earlier, this is using Happy instead of Express. So any web framework you want to use, no web framework, I hear that's popular, you can just use whatever you like. We have no restrictions on the NPM modules you can import. The real magic here, though, is happening inside of vision.js. And this is on GitHub. You can go check this out. You can see here, the first thing we do is import the gcloud npm module. Now, this npm module, it has access to all of our services. So I just happen to be using 2 in this part of the code base. I'm using the Vision API and the Storage API. Now, the real interesting piece of this code is right here, and it's these 4 lines of code, so lines 22 to 25. And those 4 lines of code, we're downloading a picture from Reddit, we're saving it to Google Cloud Storage. This right here is using Node.js. It's just using the standard Streams API, just like you would with FS, to pipe the image after we download it directly to Google Cloud Storage. And then once that's done, we're going to run it through image analysis that tells us if it's a dog, a cat, or neither, or both. That's magic. That's 4 lines of code. We just deployed something into a scalable file system in the cloud and ran an image analysis of it that I could have never, it would have taken any of us years and years and years of collective knowledge to go build. And that's really the magic that's behind this thing. So after we've evaluated all of these images, we're then, I mentioned, publishing it up through Cloud PubSub. And that's what lets our front-end nodes know that the image analysis on one record is done. Let's take a quick peek at that code. Again, using the gcloud npm module. And Google Cloud PubSub has this concept called a topic. Think of it kind of like a channel. And the idea is that I can publish many things into a topic, and then consumers will all create subscriptions to that topic to read it out later. We'll see this in a minute. So we're going to get a topic, and then we're going to publish our events as they get published from the back-end service. So we're going to say, is it a dog? Is it a cat? Is it both? It's important to be fair. And then finally, we're going to take that data and publish it out to the front end. So now let's take a look at the front-end web process. This one also happens to be Happy.js, but the real interesting code is in here inside of cat relay. Probably the first and last time I'll ever create a node module called cat relay. And here you're going to see similar code importing the module. I'm using pubnub to send messages out to the connected web clients, but you can use Firebase for this as well. I just happen to know pubnub. Grab the same topic, grab the subscription, and then here's where the real magic is happening. Get the topic, the subscription. Finally, once each of these are published, we're going to send them out through pubnub with the final message letting us know if it's a dog or a cat. Now, while I was building this application, one of the problems I ran into was I kept getting some data inside of this message object that I didn't really expect. And these kinds of things can be hard to debug, especially when you're dealing with live data coming from something like Reddit, where the shape of the JSON kind of moves around a little bit. And debugging this, traditionally debugging this locally is something that I could do, but debugging it once you're in cloud, it gets kind of hard, right? Like you have to go sifting through all the logs. And so one of the tools I had at my disposal that I want to show you guys next is called Google Cloud Debugger. So check this out. I'm going to come back over to the developer console. We don't need this right now. And I'm going to switch my projects over to the CloudCats project. And then I'm going to go into the Google Cloud Debugger. Now, I happen to have published all of my code into Google Cloud source repositories so that I have access to it for debugging. And you can see over here, the same code that we were looking at on my machine is available here inside of the developer console. This is where it gets really cool. I can come into cat relay, find that one line of code where I wanted to know exactly what was inside of that message object that I was passing through to PubNub, and we can set a breakpoint. Now, this breakpoint is not a traditional debugger breakpoint if you've used Eclipse or Visual Studio. It's a passive debugger. What this means is that people can be running against our application in production, and we're able to capture call stack and variable information without affecting performance, without stopping execution. So we can actually come back over here. I can start to run the simulation again, get a few more pages of data. And as soon as it hits this, look at that, it just hit it. That code got hit in real time inside of App Engine. I'm able to go in, take a look at the call stack, and most importantly, I can come and debug the variables that are in the local scope. So I can see, okay, this message, I want to know what data is in there. Here's the ID. Here's the data object. Here's the URL that is going out to Reddit, and the type wasn't dog or cat, it was other. So this is a pretty incredible experience if you've ever had a problem in production that you needed to debug. Another useful thing we have out there for debugging production issues. Let's say you're noticing a decrease in performance. We can also go use Google Cloud Trace. Now what Trace does is it measures the amount of time like during my HTTP request and breaks it down into each other network request that I'm making during the initial one. So for something like CloudCats, we were talking to Reddit, we were downloading images, we were uploading them to Google Cloud Storage, we were calling APIs, we were using PubSub. We had network requests all over the place. I want to measure, I want to know which ones, what's the long pole in the tent? What's making it slow? How do I debug that? And using Cloud Trace, I can do that. And here you can see, there's our sample we ran 1 minute ago. The Go endpoint is the one that I was using to measure all this stuff. And here we have it. So the request was 10 seconds long. It was doing a lot of stuff, so I don't feel bad about that. We made the first request to Reddit, second request, I asked for 3 pages of data. They have to be serial because of the way they do their next token on it. And then in parallel, we go download all the images off Reddit Media. We upload them all to Google Cloud Storage. You can see this going into the bucket. And then you can see us starting to analyze them with the Vision API. So it turns out in this case, the thing that was taking a long time is actually calling the API. But if, let's say that we found something where we needed to parallelize something that was serial, this is a great tool to tell us what's taking time during our requests for our applications with barely a performance hit in production. So when we're building our applications for the cloud and we're kind of converting from something that we have full control over, and we need to really understand how it's performing. We need these types of tools. We need Cloud Debugger. We need trace tools. We need better logging. And when it comes to building Node.js applications in the enterprise, there's no one better to talk to than Joe McCann, CEO and co-founder of NodeSource.
Nice work, dude. Thanks.
Knocking dead.
Thanks, Justin. There's nothing like talking about enterprise application development right after a cat demo. So thanks for that. So I'm Joe McCann, and I work at NodeSource. Who is NodeSource? We are the enterprise Node.js company, currently only offering the only commercial version of Node.js explicitly targeted at the enterprise use cases of Node. So a rough analogy is kind of think of us as what Red Hat does for Linux. We kind of do that for Node.js. But how did we even earn sort of the right to have a commercial version of Node.js? Well, at NodeSource, we love Node. In fact, we have the most core committers, contributors to the open source project itself, including the Node.js lead, Rod Vag, who also represents the technical steering committee on the Node.js Foundation Board of Directors. So at NodeSource, we know Node. We love it. We love the open source project, but we also really know Node in the enterprise. Right? Here's a handful of our customers that we've worked with in the past where we've seen Node at scale over the past few years. And a lot of folks, some on this slide, for example, have had challenges that they needed met. But even with these folks on this slide, I still get this question a lot. Is Node really ready for the enterprise? Now, I might be a little bit biased because I have an enterprise Node.js company that I work at. But I think the answer really is, in fact, yes, we are ready. There are hundreds, if not thousands, of enterprises out there actually using Node, from folks like Intuit to Netflix to Apple, BMW, Capital One, NASA, et cetera. It's actually more difficult to find a company in the Global 2000 that's not using Node in some capacity. So we believe, and we've seen it empirically, that Node is actually really ready for the enterprise. The thing, though, about an open source project, or even Node specifically, is when you get it into the enterprise, there are some challenges that face its adoption and integration. And the obvious ones are things around security. Is Node secure? Of course it is, but there are some additional sort of demands brought by certain industries around how to harden that runtime, or who do we call when something's broken? Who's the entity backing this open source project? And then more specifically with Node, how do we get better control over the runtime and better insight into things like finding performance bottlenecks and debugging the application? Well, this is precisely why we built our product NSolid. NSolid is, in fact, the enterprise-grade Node.js platform. And to be clear, it's not a fork of Node. It actually is Node.js with an additional set of capabilities wrapped around it. So it doesn't break interoperability. In fact, you don't even have to touch your application code whatsoever. And the capabilities that NSolid actually provides, well, they're the things that the enterprises have told us they really need. Things like enhanced security, guardrails, production monitoring of these processes, turnkey performance analysis. So we don't want to have to use a bunch of systems tools just to profile this. How do we get real-time performance analysis? Of course, I mentioned things like support, that stability from a commercial vendor. And I think one of the best parts as a developer and how we architected this early on is there's no code modification required. So the application that you've currently written in Node.js will work with NSolid by default. And I'm really pleased, earlier this week, we actually announced our partnership with Google Cloud. So NSolid is, in fact, available on Google Cloud. So let me show you a couple of demos. So let's change our project to NodeSource first. And we are actually running on Compute Engine. And so if you look here, what you'll see is a handful of VMs with some various Node.js applications. Now, in production, you wouldn't do this. You would actually run an auto-scaling managed instance group as opposed to just a handful of VMs. But it's a demo, so we can deal with this now. What you see here is a handful of apps. And this one in particular, this is Dillinger. This is a real application. It's an online markdown editor. And we see here there's some interesting CPU utilization. It's kind of hovering a bit high there, which is odd for a Node.js application. Node.js has a low memory footprint and typically has a low CPU utilization. So something's interesting is going on. And in the Google Cloud Developer Console, we can see it from a high level. But what NSolid does is it provides us deeper insight from a bottoms-up approach. So just so that you believe me, let me show you that Dillinger is, in fact, a real app. So we click on the URL. There it is running. Yes, it is, in fact, a real markdown editor. And then if we want to go dive in deeper into Dillinger to kind of triage what the issue is, why is that CPU running so high, we're actually going to launch into the NSolid console. So all of those applications that showed previously on the Developer Console for Google Cloud are all right here in the NSolid console as well. And lo and behold, we're going to dive in deeper into Dillinger. And we can see very quickly that there are a couple of processes that are kind of scattered out there towards the right. Now, it might be a little difficult to see from here, but the x-axis is measuring CPU utilization, and the y-axis is memory. And what we've noticed from the folks that we've worked with in the past at NodeSource is that some of the two major key issues that people have with Node.js development is memory leaks and determining where our bottlenecks are in our code. So we already can see quickly there is something kind of going wrong or interesting, something worth inspecting, I guess you should say, with this particular process. So if we look, we get a little bit more detailed view here, but it's not really telling us much because there's not any load actually hitting it. So why don't we go ahead and we'll go ahead and trigger some load with Apache Bench. This is an open source load testing tool. Actually, Google has a really awesome distributed load testing tool, but just for ease of use, we'll just go with Apache Bench for now. So given the latency of the Wi-Fi and anything else, what we should see in near real time is these processes actually reacting to the traffic. And what we want to do with a few clicks of the button is actually profile this application and generate what's called a flame graph. And if you've never generated a flame graph, it's OK. Basically, what you're looking for in a flame graph is the width of these function calls and how long they're sitting on the CPU. And what we can see very quickly here is this average time function. It's taking up 77% of the call, the CPU utilization for this particular process. Now, what we're doing here is somewhat magical, but it's meant to actually help drive towards issue resolution faster. We can see from this line here, this is actually where that function is defined, and we can immediately go and figure out what went wrong with the writing of that function to make it so slow. This is only a snapshot of the capabilities that NSolid provides. We do have a booth out front. I recommend people coming by to see some of the enhanced security guardrails that we have, show you some of the heap snapshot capabilities. But in the meantime, I will say I'm really excited to be working with Justin and the team because the scale of Google Cloud and the history that they have behind compute-intensive tasks, coupled with something like NSolid, really can help drive home Node.js apps in the enterprise. Thank you.
Great job, man. Thank you, Joe. So we've done a lot today. We've run JavaScript on the client. We obviously had a few demos there. We ran it on the server. That's kind of one of my favorite things about Node.js and about JavaScript specifically is that it runs everywhere. We're running it on our phones, on our desktops, on servers, and now we're even seeing it start to run on other alternative devices. One of my favorite quotes out there comes from Jeff Atwood of Stack Overflow Frame, which is, anything that can be written in JavaScript will eventually be written in JavaScript. And I think where we're really starting to see that claim come to life is with the Internet of Things. So IoT is exploding right now, and one of the top languages that people are picking to choose is JavaScript. And a big reason for that is that it's ubiquitous, it's everywhere. People already know it. All those skills that we've learned throughout the last 10, 15 years building front-end JavaScript apps, and now the last 6, 7 years building back-end apps, we can apply to devices in the cloud as well. There are a lot of great options out there. If you have something like an Arduino, or if you have something like a Raspberry Pi, there are some NPM modules, Johnny 5, Cylon.js, that make using these devices really, really simple. And Google's getting involved here too. We have things like Brillo and Weave, some new protocols and tools that are out there to help, and even help connect them with Android. Now, when you do build something that's IoT-based, let's say that we go out and we have a car or a washing machine that's internet connected, you're going to generate a lot of data. BigQuery is a great tool that we can use when it's time to actually tame that data and try to gather some insights out of it. But all that sounds, all that sounds great and exciting. What I wanted to do today is, we have a little bit of time left. I think we have 6 minutes left. I want to have some fun. And what I want to do is I want to show a toy. Now, these toys right here, and they may be kind of hard to see, these are called Little Bits. And Little Bits are these tiny little electronic building block components. They're great for the young or the young at heart. And they're about teaching children electronics and about getting excited about making things. I know that's something that I wanted to share. And so the next part we're going to dig into is how we can use Little Bits, connect them to the internet, and then actually control them with Node.js on Google Cloud. So before we dig into the actual demo, I want to take a look at a little bit of code. There we go. So this is the hat spin project. And I'm going to open up server.js. And you can see I'm back to using Express again. And I just want to walk through a few of the NPM modules I'm using and talk about how they're going to communicate with these devices. So here we have the LittleBits API. And that's using LittleBits Cloud HTTP. And they have an NPM module that you can install that will actually communicate with this thing over cloud. Pretty simple to use. Again, I'm using PubNub to connect to an internet-connected client. So we're going to see a web page here in a little bit. In this case, I happen to be using Redis to store a few results. So you could use Google Cloud, you could use Memcache, but if you want to come use Redis, that's perfectly fine. I'm using Redis Labs as an example right here, just because it was easy to set up. And then let's get down to the part that's actually doing something interesting. When you guys click on a button in a link that I'm going to send you out in a little bit, I'm having a little bit of problem with my device. I have to reset it over here. Give me 1 second. Make sure that my phone is serving everything the way it's supposed to. All right, sorry for the interruption. And so with a little bit of luck, assuming the technology doesn't fail us today, this is all very new. Every time we come in here and click, we're going to count. We're going to try to get up to 100 clicks. And once we get to 100, we're going to send a 20-second high-edge signal to a device. So now let's take a look at what type of device we're going to use. So some of you may have seen this movie where there's a bunch of guys that try to get a job at Google. And in the end, they do get a job. And when they're finished with that, they get one of these fancy hats, right? Now, I was very excited when I got my Noogler hat. And the very first thing I thought to myself when I got it was, you know what? I better connect this thing to the internet. Because I'm at Google now, and that's what we do, right? And so, oh my gosh, it's not starting up. And so I went and we built this. And what I want everyone to do is I want you to go out to hatspin.net and see if we can coax my hat to wake up and activate. Unfortunately, right now, it's giving me a little bit of trouble. But I'm going to hope for the best. And worst case, I look like a fool in front of a room full of people. Whatever, wouldn't be the first time. All right, so I'm running hatspin over here. And what I can do is I can actually watch. Oh. Yeah, let's hear, I'm going to reset it. All right, if you voted, oh my gosh, you guys are voting so fast. All right. Unfortunately, it's having a little bit of trouble with the Wi-Fi, even though it was working earlier. I apologize, folks. I'm going to get this working after the event if you want to come up and see it, and we'll give it a try again in a little bit. Darn it. All right. So we covered a lot of stuff today. We had some ups, we had some downs, we had some hats. App Engine is making it easy to operate Google at Google scale. So the applications that you're writing today, we want to make it as simple as possible for you to focus on building the app and not having to worry about the infrastructure. You can use the tools and libraries you're already using, use the things that you know, the things that you love. When you are ready, if you want to take advantage of our amazing APIs and services, that's available to you, and that's really the magic that's behind Google Cloud. And finally, the big thing is that Node.js and Google Cloud, together, we're all ready for the enterprise. We're ready for serious applications, not just hats and cats, but we're ready for the real applications that are needed out there today to change the world. Everything we looked at today, end-to-end, is open source. The Docker images we're using, the gcloud NPM library, trace and debugger tools, the API client, all the samples, everything we're doing is in the open and the clear, and we want your feedback on this. Get involved, open issues, tell us if something doesn't work, tell us if it does work and you like it. We want to make sure that you get involved. And lastly, thank you.